Today we're going to learn about different kinds of answers we might get for our systems of linear equations. So in the past, we've been working with just getting one solution for our answers, and a one solution answer is when the lines intersect at one point. So this is what we've been working with. It's when you're graphing a system, which is two or more linear equations. And then when you graph them, let's say we have a line that goes down here, and let's say we have another line that is a vertical line, okay? And the answer to a system that we've been working with has one solution. That's that one point where they cross. Okay, and when we're solving it mathematically through substitution or elimination, you'll have an answer as a coordinate of x comma y. So you might have a coordinate of 2 comma 0 as your answer. So that's what we've been working with so far, but there are options where you might not have a solution or you might have infinitely many. So that's what we're going to talk about today. So, for a no solution answer, it's when the lines are parallel and therefore do not cross. So let's say we have two horizontal lines, okay? So we have this line down up there and my green line down underneath. If they're parallel, they don't cross. And so we don't have an answer because the answer is when they cross. So they're going to be parallel if you were to graph, but if we also were solving mathematically, we're going to think back to when we're solving equations. And if we had crossed out our variables and ended up with a 2 equals 5, it does not work and there's no solution. So we are going to see this again in terms of solving equations. So if our variables are gone, our x or our y, or both, are canceled out throughout solving, and we're left with something that is not equal to each other, there's no solution there. Then we have the opposite. It's infinitely many solutions. So infinitely many solutions mean that the lines are the same and they overlap each other. So maybe when you were graphing, all right, you graph this first line and you're like, okay, now let's go to the second one, and you end up graphing the exact same line. That means every single answer on the line is an answer to you, and lines can go on forever, infinitely. So that's why there's infinitely many solutions. Now, if we also think back to solving equations, we would have answers that would equal each other, such as 3 equals 3. Again, this is when our variables cancel out, and when that happens and our final answer is completely equal, then we have infinitely many solutions, and that's what you can also get. So now we have 3 options for answers, not just one. So let's go ahead into our examples to see what kind of answers we're going to receive. So the first ones, we're going to go back to graphing, and we're just going to graph these in slope-intercept form. So I'm going to do the first example, the first linear equation in purple. So I have y equals 3x plus 1. I go to my plus 1 first on my y-intercept, and my slope is 3, which is really 3 over 1. It's positive, so I go up 3 over 1, up 3 over 1, or if I lose space like I just did, I go down 3 to the left 1, and I continue that line. So once you have enough points, you're able to connect the dots. Hopefully your line is a little straighter than mine, and that's the first line. And now I'm going to do the second one in orange. So I start with my y-intercept of -3, and then again I go up 3 over 1 for my slope. So as we're noticing this, you might remember, or hopefully it looks a little familiar, that, hey, they had that same slope. They have both a 3, so they have a same slope, which means that they're parallel, and if they are parallel, they will never cross, which means we have no solution to this system, and that's your final answer there. Let's go ahead and try the next one. So again, I'm going to start with my purple. Okay, we're going to start with our y-intercept of +5. So we're going to go up to 5, and I have a slope of -2. That means I go down 2 to the right 1. This creates a negative slope from left to right when I read it. It's going down, you're sliding down. So we have that graph right there, and now I'm going to do the second one again in orange. My y-intercept is at a +1 on the y-axis. And again, I have that -2 slope, which means I go down 2 over 1, and I continue it. So you guys can already see, again, it's just like our first example. They have the same slope, which means they're parallel. So that means they will never cross, so there's no solution to this answer. And that is your final answer. You must write no solution for me to understand that you understand the whole answer. Now we're going to solve the next two in mathematical form. So I'm either going to do substitution or elimination. So we'll see what kind of works best for us. In this first one, I see that our variables are all lined up, but also I see that my y coefficients are a 1 and a negative 1, which means that they're opposites, which is great. That's what we want. So I'm going to solve by elimination. So all I have to do is, since they have opposite coefficients, I just add my equations vertically. So my x's combine like terms, and I'm left with 2x. My y's have a positive 1 plus a negative 1, which cancel out. They're eliminated. And it's equal to 3 plus a negative 3, which is 0. We can still solve for x because it's still there. So I go ahead and divide by 2 on each side. And when I get 0 divided by 2, we follow through and we make that an actual 0. So when we start writing our coordinate, we have our x comma y, and we have our first coordinate as 0. To find your y coordinate, you just substitute in your 0 into either equation. It doesn't really matter. I'm going to do it in the first equation. So instead of x plus y equals 3, you have 0 plus y equals 3. So the 0 can kind of cancel out itself. So you're left with y equals 3. And this is a one solution answer to your system. In this next example, I'm going to use elimination as well. This time, though, I do not have any coefficients that are the opposite. So what I'm going to do is multiply my first equation by a negative 2. This will help me because I will have my coefficients for x as the opposite, because negative 2 times 2x is negative 4x, and that's exactly what we would want. So I'm going to rewrite my equation. And so negative 2 is going to be distributed to all three parts of my equation. So I have negative 4x minus 2y, because y times negative 2 is negative 2y, equals negative 10. And now I'm just going to bring my second equation on over. So I have 4x plus 2y equals 0. Now we're going to eliminate by adding both equations together. Negative 4x plus 4x is 0. It cancels out. But also negative 2y plus 2y is 0. That cancels out. So on the left side of my equation, I'm left with 0 equals a negative 10 plus 0 is negative 10. So this is that situation that we talked about earlier where you don't have any variables left, and we have a situation where our equation is not equal. 0 does not equal negative 10. So because of this, we have a no solution answer. Go ahead and try the next 4 problems on your own. Remember that if you end up with something like 0 equals 5, that is no solution. If you have something that says 0 equals 0 or 7 equals 7, that's infinitely many solutions. Or you might have an actual coordinate point like 0, 2, and that's an actual one solution answer as well. So these are going to be a little mixed up. Check back and see if your answers are correct. All right, these are the answers you should have received. We had a couple no solutions. That means that they're parallel lines if you were to have graphed them. You also would have gotten such answers that would have been like 2 equals 5. They aren't equal. You would have that mathematically. We then had an infinitely many solutions. That means that you can easily be given a 0 equals 0 situation. It's equal, yet there's no variables. Or if you graphed it, they'd be the same line. And then the very last one is actually a coordinate that these two lines will cross at -1/3, 0.